let's take a look at how to graph a line with a restricted domain. In other words, we're not going to be really graphing lines this time, but really rather rays or segments, because our lines are not going to go through the entire graph. So let's start with this one. My function is f of x is equal to negative 2x, so this the equation of a line. But I'm only going to graph this where x is less than or equal to 4. So the way that I would recommend doing these is let's actually make an xy table. Even though you're probably very familiar with graphing a line in slope-intercept form, you'll see that with these restricted domain lines, sometimes slope-intercept form doesn't actually work out very well for you. So I'm going to pick 3 points for x, and I'm always going to use the value that I have in my restricted domain to begin with. So I'm going to put 4 in my table. And actually what I'm going to do in my graph right away is something special is going to be happening when x is equal to 4. So I'm going to draw this sort of invisible wall on my graph where, again, something special will be happening. Okay? Then I need to pick a couple more values for x so I have enough to draw my line. And remember, my domain said x had to be less than or equal to 4. So I have to pick numbers smaller than 4 for x. So I don't know, maybe 3 and 2. Alright, well what I would do is what I would always do when I am plotting points or finding a table of values, plug in these values for x into the equation they gave me. So plugging in plugging in 4 into that equation, negative 2 times 4 is negative 8, so there's a point. 3 times negative 2 is negative 6, and 2 times negative 2 is negative 4. So now I have 3 values that I can plot to help make my line, although remember, it's not really going to be a line. So the first point we found was 4, negative 8. So if I count 4 spaces, I'm on the wall. So remember, we want to be really, really careful, and I need to make a note of whether I can or cannot have a point on that invisible wall. Well, remember, my domain was x was less than or equal to 4. So actually what I like to do is, I guess I should have done this earlier, is in my table, I'm actually going to put a filled-in circle next to 4 to remind myself that I can be equal to 4. If I couldn't be, you may recall I would use an open circle to do something like that. But this time I am allowed to be equal to 4. So anyway, back to my graph. I'm going to plot the point 4 and then negative 8. And again, I can be equal to this. I can be on the wall. So I'm going to make a really big point there so I can see that it's a filled-in circle. After that, I'm going to plot my other points on this line, which were 3, negative 6. And at this point, if you know slope-intercept form, you can kind of see that I could just count up 2 and backwards 1 if I wanted to. And then my next point was 3, negative 4, so again, point right there. And so I can start to see what my line is going to look like. Well, this time, rather than draw a complete line like this, remember, I'm going to draw my line, but it's going to stop when it gets to that wall. So really, I only have a line, I prefer you guys use a ruler or something, I only have a line that looks like this. In other words, a ray. It begins from this point on the wall and continues in one direction, all this side of the graph, because that's where I'm less than 4. Okay, so let me go ahead and clear this one out so this doesn't get too messy, and we'll try the next 2 as well. This time I want to graph the line g of x equals 1/4 x minus 1, but only when x is greater than negative 2 and less than or equal to positive 2. So this time I've got 2 invisible walls to draw, 2 barriers. So I've got a barrier at negative 2, something interesting will be happening there, and then a barrier at positive 2, so I'll go ahead and draw that in as well. This time we won't even have a ray, since I have 2 sort of walls I'm going to be between. I only have a segment this time. Okay, so again, even though slope-intercept form is the quickest way to graph a line, it doesn't always work out so well when you're trying to do one with a restricted domain. So I'm going to do an xy table. I want to include those special values, so I'm going to include negative 2, and I'm going to include positive 2, and then because I want to have a third point, I just need to pick anything in between those, so 0 is probably a great point to pick. Okay? Even before I plug these values in, I'm going to make note in my table of whether I can or cannot have a point on those special values. Well, at 2, it says I can just be greater than 2, so I'm going to have an open circle at negative 2. And then over here at positive 2, I can be less than or equal to that. So I'll include a filled-in circle in my table. Again, that's just a reminder for me what kind of point to use. All right? From here, I'm going to take my x values and plug them into this equation. And I apologize for the small numbers we'll get, but so be it. I can do that on a table on my calculator, but it should be easy enough to plug these values in by hand. Well, 0 is easy enough to plug in. I know I get negative 1. For y when I do that. If I plug in negative 2, I get negative 1.5. And if I plug in 2 for x, I would get an output of negative 0.5. So let's go ahead and plot those 3 points and see what this segment looks like. So once again, I had a point at 0, negative 1. I had a point at negative 2 And I'm on the wall, so I want to be careful over here, and then down 1.5. And I made a note, it was an open circle because I can't actually have -2. It says I'm not allowed to be equal to -2. And then I have a point that's +2, again on the wall, and down a -0.5, so about right there. And this time I have a filled in circle. Make those endpoint circles really big so I can see if they're filled in or not filled in, and then go ahead and connect, and there, that itty bitty little piece is the segment that that's talking about. And finally, this last one's a little bit weird. Notice the equation is just h of x is equal to 3. So I'm going to have a horizontal line. However, I'm only going to have a horizontal line if x is equal to 1. If x is not equal to 1, nothing's going to happen there. So again, let me draw a wall at where the special boundary line is. I'm going to go ahead and draw my dashed line at 1, so something special is happening there. If I try to make an xy table, watch kind of what this looks like. It says my output is 3 no matter what. So no matter what numbers I plug in for x, whether it's like 0, 1, 2, 3, my output is 3, with one exception. It says if I plug in 1, nothing happens there. So at 1, there's just going to be a blank space. In other words, on my graph, when I get to, or let me go ahead and plot these other points first. So like 0, 3 is a point right on the graph. Like I have this horizontal line going through 3, but as soon as I get to when x is 1, there's a hole in the graph. So my line can extend this way because that's where x is not equal to 1. And my line can extend even that way this time. The only space where this line won't exist is right when x is equal to 1. So I said this last one was kind of weird. There's just a hole in the line when x is equal to 1.